Christopher King, co-founder of Broke Boys Incorporated. And do we have an ingenious little product for you? It's called the Box of Evolution. And it can turn any old, any day object into a modern masterpiece.
I wanted a MacBook, but all my mom got me was an iPhone. I have my Box of Evolution. All I have to do is put the phone in here, close the box, and say the magic word. But the magic word is only for the people who buy the box. And it turns into a MacBook!
I need to make a box with a volume of 1500 inches cubed. What am I gonna do?
Sounds like you need some help, Chris. Howdy. My name's Ian Torres, optimization expert, and I'm here to help you with your calculations. Now, using our equation, we can find the first derivative and find our length. Use the second derivative test to make sure that it is in fact a minimum, and plug those back in to the original equation to find our minimized cost at $163.54.
Well, now that I know how much it costs, I need to figure out how much I need to charge it for. But how do I do that?
Well, that's just an excellent question, Chris. Let's say we sell 1,000 boxes. We find that equation, find the first derivative, and get x equals 19.549, where x is the number of $15 increases. We can make sure that x is the maximum using the second derivative test once again. Finally, we can get our max revenue by plugging it back into the original equation.
Well, now that I know the total cost and the total revenue, all I need to do is figure out how many of these babies I have to sell in order to turn a profit. How do I do that?
All we need to do is a little bit of subtraction. Subtract cost from revenue and you get profit. Then you get the first derivative of that function and you should get x is 25. Now use the second derivative test once again. Notice that each x value represents 100 units. Therefore, 2,500 units must be sold to max profit. Seeing as the Box of Evolution is going to be a commercial success, we have already begun designing an upgraded version. This time, we wish to have a slimmer look than before, while having it hold the same amount as its predecessor. This means we need to minimize surface area. Using the same strategies as before, find the first derivative of the function, find the zero, and that becomes your x. Use the second derivative test one more time to clarify that your x really is a minimum. Now plug in x to get your height, and now you have the dimensions to minimize surface area.
That wasn't that fun. Now remember, we may be broke boys,
But we're not broke, boys.